President. I am P.Kumar of EEE Education Center. Within these sessions, we will discuss about the electric field intensity due to the point charge. First of all, what is the electric field? Electric field is the force experienced by the unit positive charge. If we say that here is the Q charge and at the distance of this Q charge, P is the point and we have to find the electric field at this point P. If you have to calculate the electric field intensity at a point P, it means there is a unit positive charge. Here is unit positive charge. And we know that the electric field is the force experienced by the unit positive charge. So the electric field, this is the vector quantity and this is equal to 1 upon 4 pi epsilon naught q by, and the distance between this point Q to the point P is equal to R, that is equal to R square. So the electric field, the directions of the electric field, we have to find the electric field at this point P. If here is the positive charge, then the force of repulsions will exist between the unit positive charge and Q charge. So the directions of the electric field is along the directions. What the directions of the force? That will the directions of electric field intensity. So the electric field due to this Q charge at a point P is equal to E is equal to 1 upon 4 pi epsilon naught Q by R square. If there is the more than the two charges, here is the Q1 charge and here is the Q2 charge, and the P is the point at this point. Here is, that is equal to R1 and that distance is equal to R2. From the point Q1, the point P is at a distance R, and from the point Q2 charge at a distance R2, we have to find the electric field at a point P. We know that when we have to find the electric field at any point, there must be unit positive charge. At this point P, the electric field due to this plus Q1 charge will be along the directions. And the electric field due to this Q2 charge at this point P will be along the directions. This is the positive charge, this is also the positive charge, and this at this point it is the unit positive charge. And this angle is equal to theta, so this angle is also theta. So we can consider this is equal to E1 and this is equal to E2. So if you have to find the resultant electric field at a point P and the angle between these two electric field is equal to theta, so that can be calculated with help of the vector additions method, and this is equal to net electric field at a point P is equal to under root E1 square plus E2 square plus 2 E1 into E2 cos theta under root. Putting within this, putting the value of E1, E2 and 2 E1, E2 cos theta, we can calculate the net electric field at a point P.